So welcome to our first lesson on the series reaction rate. Okay, so let us say we have a volumetric flask here. In the flask I have some acid. The acid is HCl. Also in the flask I have a metal, and the metal is zinc. Okay, so you would remember that when a metal reacts with an acid, okay, the products are going to be a salt and hydrogen gas. Okay, so in this example here, the metal is zinc, okay, and this is going to be in solid state. It reacts with HCl, an aqueous solution of hydrochloric acid. The product, the salt that is produced, is going to be zinc chloride. Okay, this is also going to be in the water, so it's an aqueous solution. And lastly, we will have hydrogen gas. Okay, so if we balance this, we're going to write a 2 here to balance the chloride atoms, the chlorine atoms. So we have 2 chlorine atoms on the right hand side. Now if we put a 2 behind the HCl, we'll have 2 chlorine atoms on the left hand side, but that also balances off the hydrogen atoms. Okay, so now the chemical reaction is balanced. Okay, so but one thing that you must remember with the gas, so if a gas is produced in the flask, we're going to observe gas bubbles on the surface of the liquid here, the HCl, but that means the hydrogen gas will be escaping into the atmosphere because the mouth of the flask is open. Okay, so now we have our reactants and products. So what I want to tell you is that in a chemical reaction, okay, in a chemical reaction, okay, so the amount of the amount of any reactant is going to decrease. So in a chemical reaction, okay, the amount of a reactant decreases over time. Okay, so this is very key, that any amount, by amount we mean like concentration, either concentration, okay, mass, volume, right? So concentration, mass, volume, mole. Okay, so either concentration, mass, volume, or mole of any reactant is going to decrease over time because the reactants are getting converted into a product. Okay, so but if you look at the product, the amount, by amount I mean concentration or mass or volume or mole of a product, okay, increases over time. Okay, so the keyword is increases. Okay, so you would remember that in any chemical reaction you have an excess reactant. Okay, so the excess reactant, this is going to be the reactant that remains after the chemical reaction is complete. Reactant that remains after the chemical reaction is complete. After the chemical reaction is complete. Okay, so we also have a limiting reactant or reagent. Okay, limiting reactant. Okay, so this is the reactant that is completely used up in the chemical reaction. Okay, the reactant that is completely used up, it is finished in the chemical reaction. Okay, so now let's combine these facts. Okay, firstly, the amount of any reactant decreases over time during a chemical reaction. Okay, the amount of product increases over time during a chemical reaction. And secondly, an excess reactant is the reactant that remains after the chemical reaction is complete. A limiting reactant is the reactant that is completely used up in a chemical reaction. So what I want to do now, I want to represent what I've just said graphically. Okay, so let's just draw. I'm going to draw a graph here, right? A graph of a mass of HCl versus time, right? So let's say maybe let me draw the mass of zinc. Okay, let's draw the mass of zinc. Okay, so remember that let's say mass of zinc here in grams. Okay, this is time. So this is going to be a graph of mass of zinc versus time, Okay, so if let's scroll up a bit. Remember what I said. I said in the flask we're going to put zinc. Okay, so a certain amount of zinc. So let's say the mass of zinc I put there was 10 grams. Okay, so initially, okay, at time equals to 0, at the instant where I put together the zinc and the hydrochloric acid, the mass of zinc will be 10. Okay, so now here let's say this point is going to be 0 and 10. Okay, so over time the mass of zinc is going to decrease as the zinc is being as it reacts with the hydrochloric acid. It is converted, it is giving us product. So the mass of zinc is going to decrease. Okay, so we can therefore say the mass of zinc decreases over time. So, okay, so if it decreases to 0, right, at this point, let's say the time value here is 60. Okay, so at this point the coordinate of this point here is going to be 60 and 0. So what does that mean? The mass of zinc, okay, decreased from 10 grams to 0. So all of the zinc was used up in this chemical reaction. So and therefore zinc is the limiting reactant or reagent. Okay, because what I'm showing you here on the graph, I'm showing you that all of the zinc reacted during the chemical reaction, and therefore it is going to be regarded as the limiting reactant in this case. Okay, so what about the product? Okay, so the product, if you look at let's take a hydrogen gas for instance. Okay, so we can say this is a reactant. Okay, and we can also plot the graph of a product. Let's say this is the graph that represents the mass of hydrogen gas in the chemical reaction. Okay, so what's going to happen over time? As soon as I put together the zinc and the hydrochloric acid, we're going to start getting product produced. Okay, so now, but when we start at time t equals to 0, when we start the chemical reaction, we don't have any product. Products are going to be produced as the chemical reaction progresses. Okay, so this graph is going to start here at the origin. Okay, so on the vertical axis I have mass of H2 hydrogen gas in grams. Okay, so this graph must start here at the origin. Okay, the curve is going to start here at the origin, and it increases like this. The gradient changes until the graph is straight. Okay, so when the graph becomes constant, okay, let's say 60 seconds here. Okay, so the graph becomes constant after 60 seconds. So what does that mean? There is no more increase in the mass of hydrogen gas produced. Why? Because remember, in a chemical reaction we have a limiting reactant and the excess reactant. So after 60 seconds, this graph, our first graph, shows that the limiting reactant, which is zinc, is finished. Okay, remember that zinc is reacting with HCl. Okay, when the zinc is finished after 60 seconds, as shown by the first graph there, okay, when the zinc is finished, the HCl, being excess reactant, will have nothing to react with. So it means from that point onwards, we are not producing any more product. Okay, so and therefore after 60 seconds, the mass of hydrogen gas produced is not going to increase. It's going to remain constant. So this graph here is going to be a horizontal line after 60 seconds onwards. Okay, so this is going to be the graph of mass of hydrogen gas versus time. So this is a product. Okay, so it shows that a product increases, right, over time, okay, until the reaction has stopped. Okay, so in this case it has stopped after 60 seconds. Okay, so I could also plot a graph of concentration versus time. This could be, I could plot a graph like this. Okay, so if I plot a graph of concentration versus time, so this going to be time in seconds. I put a 0 here. This could be a concentration. Okay, right, this is concentration of, say, HCl, the reactant. This is going to be mole per cubic decimeter. Okay, so if we start the reaction, the reaction is going to start with a certain amount of HCl. So the concentration of HCl at the start of the chemical reaction will be higher, but it's going to decrease over time, right? And then at some point this graph is going to be constant like this. Okay, so if I put 60 seconds here, I'm saying this chemical reaction took 60 seconds, right? So please note that this does not decrease to 0 because this is excess reactant. Okay, right, so we start off with a certain amount. Let's say this point here I have 0.5. okay, but after 60 seconds here I have 0.2. so what am I saying? I'm saying the excess is the excess concentration of hydrochloric acid is 0.2 mole per cubic decimeter. Okay, so at the start we start with 0.5, right? After 60 seconds we have 0.2 mole per cubic decimeter of HCl remaining in the flask, because this is an excess reactant. Okay, some of it does not decrease to 0, some of it remains once the limiting reactant has been finished. Okay, so I could draw a concentration of a product. Okay, so this could be a concentration of if I put 60 here, this is time in seconds, and this is going to be here concentration, right, of hydrogen gas. Okay, this is going to be in mole per cubic decimeter. Okay, so the graph that we draw could be any amount. It can be mass versus time, it can be concentration versus time, it can also be volume versus time. So it depends what we like to draw, but what is important is that the is for you to remember that the reactants, a reactant is going to decrease in amount over time, but a product is going to increase in amount over time. And we also distinguish between excess reactant and limiting reactant. Okay, so this takes us to the end of our lesson. See you on the next one.